Good afternoon, everybody. Welcome to Autoscaling Prime Time. How are you all doing? We're in the final few hours of reInvent. Are you hanging in there? All right. I'm Tara Van Unen. I'm the Product Marketing Manager for our Automation and Messaging Services. And I honestly almost didn't make it up here today. On day 2, I entirely lost my voice, and you can still tell that it's strained. And my body just doesn't respond so well to the demands of reInvent. And I expect that many of you are feeling the same way. So I've been thinking, wouldn't it be great if we could autoscale ourselves like we autoscale our apps? But we're not nearly as elastic as the cloud, and I don't have a solution to tell you for self-scaling. But I do have a solution that can save you a lot of time and a lot of effort when scaling your applications. And my friend Vadim will be coming up here in a bit to share how this solution is helping the engineering team at Netflix to change the way they do scaling. This session is all about dynamic scaling. And dynamic scaling is one of your most powerful tools to take advantage of the elasticity of the cloud. It allows you to scale your resources in and out in response to changing demands. Here's a quick example of how it works. Here we have a couple of EC2 instances in an autoscaling group behind an ELB. And the metric that we want to scale in and scale out on is our average CPU utilization, because we've determined that this metric has an impact on the performance of our app. So as that CPU utilization starts to climb in response to an increasing amount of traffic, autoscaling will automatically spin up additional EC2 instances in order to bring that CPU utilization back down to keep your performance in check. And this provides 2 benefits. First, it helps you to reduce cost because you're paying for capacity as you go, as you need it, instead of provisioning for peak capacity up front. And it also helps you to improve the availability of your application because you're able to manage performance. And our customers that have horizontally scalable applications are using dynamic scaling extensively today. I mean, Amazon.com uses auto-scaling to handle the significant increases in traffic that come with Prime Day and Black Friday. How many of you were at the session yesterday, the auto-scaling session with NASA JPL? In that session, they showed how they're using dynamic scaling to scale the processing of data from their Earth-observing satellites in order to improve the response times for the emergency teams on the ground following hurricanes and earthquakes and volcanoes. And of course, Netflix uses auto-scaling to handle those prime times for traffic, like after the recent release of Season 2 of Stranger Things. But as you have seen from this week, we constantly iterate and innovate on our services. And in order to do that, we work backwards from our customers. So about this time last year, we did a survey of autoscaling users like you to find out what was working and what was wanted with autoscaling. And here are the top picks. The first pick is all about speed. Customers tell us they want a super simple way to set up scaling policies. They also tell us they want us to bring autoscaling to more AWS services. They want to be able to supersize a wider range of resources. And lastly, they tell us that they want to become masters of metrics, meaning they want us to provide guidance and tools and techniques that help them understand what metrics to use when and what value. So I'm going to show you what we've done to deliver Speedy setup and more services for autoscaling. And Vadim is going to share with you some tips that they've learned at Netflix for mastering metrics. Sound good? Good. So since speed is relative, right? So let's look at the step scaling policies that most of our customers have been using for the last few years. With step scaling, you pick a metric you want to scale on, and then you set a number of scaling adjustments for that metric. You're accountable for determining how many instances to add or remove at different thresholds for that metric. So it gives you a lot of control over your scaling adjustments, but it also gives you full ownership over all your scaling adjustments. And some of our customers, they want that ownership. They want the ability to set really granular scaling behaviors and do all the fine-tuning themselves. But as you saw from our survey, many of our customers just want to set the metric and be done with it. Which is why earlier this year, we launched target tracking. And I like to call target tracking the upside down of step scaling. Because with target tracking, you don't have to worry about a single scaling adjustment that's under the hood. It works a lot like a home thermostat. But in this case, instead of setting the temperature, you're setting a target value for a metric that you want to keep. So you just set the metric, and target tracking calculates how many instances to add and remove from your autoscaling group in order to maintain that metric. So you just set it and forget it. Look at how easy this is. 3 clicks. Setting up this scaling policy, you name your policy, you select your metric, and you set your target. And target tracking is self-optimizing, meaning there's an algorithm that measures how that metric is changing over time. And this allows you to minimize both overscaling and underscaling, as well as any oscillations. And it also gives you the fastest scaling response time because it's constantly calculating how many instances to add or remove based on the difference in the value, the actual value of that metric versus the target. Let's take a look at how this works in a scaling out example. So once again, we have EC2 instances in an autoscaling group behind our ELB. And for this application, the metric we've chosen to scale on is CPU utilization. And we've set our target to 50%, as you see in the gold dashed line. And at the current level of traffic, those 10 EC2 instances are able to maintain that target CPU. But as you increase traffic to the ELB, and that in turn increases traffic to the instances, your CPU utilization starts to climb. So target tracking will do all the calculations to determine how many EC2 instances to add to that autoscaling group to bring that CPU back to the target of 50%. And in this case, it adds 5. And then it brings your traffic and your CPU in a manageable, in a condition that can manage the performance of your application. I want to show you how this works in an actual demo. So we have set up a typical web application, typical 3-tier web application. At the top layer, we have our application load balancer that manages the incoming traffic and then distributes that traffic to the EC2 fleets within an autoscaling group at the compute layer. And autoscaling automatically balances your EC2 instances across AZs for fault tolerance and high availability. And then the application uses DynamoDB at the data layer. So for the demo I'm going to show you, we've set our target tracking scaling policy at the compute layer so that it adds and removes EC2 instances as the traffic changes. But you could also set target tracking scaling policies at the data layer for DynamoDB tables so that it adds or removes provisioned capacity as the traffic changes. And I pre-recorded this demo because, like my voice, I can't rely on Wi-Fi. And also because we wanted to make this available to you on our website for reference after reInvent. So we're going to start in our EC2 console. From here, we're going to go into our autoscaling groups. And as you can see, we already have an autoscaling group set up. And we have attached, in the Details tab, you can see we've attached a target group. Now, target groups are a concept with application load balancers. Target groups listen to the application load balancers as it receives the traffic. And it's what allows us to route the requests from that application load balancer to our ASG. And I'm showing you this because when I go into the scaling policy setup, you're going to see that target tracking demo for the target group is automatically populated. So let's add our policy. We're going to give it a name. I chose the name Mad Max. And you can see that there's a number of predefined metrics to choose from. But you can also emit your own custom metric and then pick that from the SDK or the CLI. And the metric that we're going to use to scale our sample app is the application load balancer request count per target. And in this example, the target is simply an EC2 instance. And the reason we've selected this metric is because it directly correlates with the incoming traffic to our app. And as I said, you can see that the target value that you saw in the Details tab is automatically pre-populated. And I've set my target value here to 1,000 request counts per minute per EC2 instance, because we've already done some load testing, and we see that at about 1,100 request counts, our EC2 instances start to run a bit hot. So I'm setting this here at 1,000 to give me a bit of headroom. So I set that, I hit create, and boom, we have our Mad Max auto-scaling policy set up. But now I want to see how auto-scaling behaves when it handles traffic for a 24-hour period. So I'm going to go into CloudWatch to take a look at the scaling adjustments as the traffic ramps up and ramps down, as we expect it to do through the course of a day. And there's two graphs that I want to show you with a couple key takeaways. This first graph shows you that target tracking allows you to follow the traffic extremely closely. As you can see here, the gold line, which is our ASG size, is tracking with the traffic throughout the day very closely. So it's doing all the scaling adjustments for you, and it's scaling very quickly. But the science behind this scaling behavior is really evident in the next graph. Because the next graph shows you that the auto-scaling group size is actually being dictated by our target metric. If you look here, target tracking will always add and remove instances to keep you as close as possible to your target value, in this case, 1,000 request counts per minute. So it does all of the calculations to determine how many instances to add or remove. So it's giving you the right scaling adjustments to maintain that target. So your application is able to get the capacity that it needs to handle the changing traffic without you having to make a single scaling adjustment yourself. And that's why many of our customers really like target tracking. It allows them to not only have speedy setup, but also speedy scaling. Which is why when we brought autoscaling to more services this year, they came out the gate with target tracking policies right away. In fact, DynamoDB, or autoscaling for DynamoDB, which we launched in June, was the very first AWS service to come out with target tracking scaling policies. And with DynamoDB, instead of scaling on EC2 instances, you're scaling on read and write IOPS. And just before reInvent, you might have seen that we announced autoscaling for Aurora. Incidentally, that's the fastest growing AWS service ever. So you can autoscale a number of AWS services. The resources that you scale on will differ, and as well as the metrics. But this gives you a lot of advantages, especially that we're bringing target tracking to the rest of these services over time. And I want to now invite Vadim to the stage so you can talk about how Netflix has been using target tracking in practice.
Thank you, Tara. Thank you. Good afternoon, everyone. Let the show begin. Let it begin. This is Vancouver, British Columbia. That's where, yes, that's where Tara is from. That's where autoscaling team is located, and that's where target tracking has been developed. Beautiful city. I've been there once. Hope to visit one more time. This is Seattle. Even if I didn't put a caption on this skyline, it's easy to recognize. The Space Needle dominates the skyline. Seattle is also headquarters of Amazon. This is what a misconfigured autoscaling could look like. My name is Vadim Filanovsky. I'm a performance and reliability engineer at Netflix. And in this presentation, I'll show you how Netflix makes our autoscaling look less like this and more like this. This is the same ASG with roughly the same traffic the next day when we fixed autoscaling policies. But first, let's talk about the need for autoscaling. Certainly, it takes some effort and some time, and sometimes a little bit of trial and error to set up autoscaling policies. Why is it worth for us? Let me show you. Take a look at these two stills. These are stills from the Iron Fist, a Netflix original. If you don't see differences between these two images, your eyes do not deceive you. These two images are meant to look the same, even though these are two distinct images. And here's the difference. One of these video streams was encoded at 556 kilobit per second, another one at only 277 kilobit per second. Netflix employs something that we call perceptually optimal video encoding to encode our content and reduce the bit rate without perceived loss in quality. As you can imagine, we need a lot of compute power to run this encode across our ever-growing catalog. Where does it come from? Take a look at this graph. The blue area at the bottom represents our normal EC2 usage. It's only a slice of it for a particular instance type for a particular region. You can see peaks and troughs, obviously, around 7, 8 p.m. A lot of people watch Netflix. At 2 or 3 a.m., only hardcore fans watch Netflix. So our EC2 usage goes down. We don't need as much capacity to support the viewing. Netflix runs almost entirely on reserved instances. What do we do with those instances during off-peak hours? We use them for encoding. We build a pipeline that allows us to use those instances, and autoscaling enables us to reuse this capacity for encoding, and that's the yellow graph on the top. Another use case, recommendations. As Netflix expands to more countries, as Netflix adds more content, more languages, we need better recommendation algorithms. Better recommendations algorithms sometimes require more capacity to run, especially as our customer base keeps growing. The bulk of it runs during off-peak hours, and we reuse the capacity that we do not use for streaming. There's a few other benefits of autoscaling. Red-black pushes. The industry standard name for this is blue-green, but I'll stick with Netflix term. We call it red-black pushes. Netflix infrastructure is immutable, which means that we bake an AMI, we deploy it, we never patch those instances. When the new version of the code is ready, we set up a new ASG with the new AMI, switch the traffic, then we remove the old ASG. Imagine if we provisioned every ASG for peak, doing red-black pushes would be pretty expensive because we would have to double up our capacity. Autoscaling allows us to reduce the cost of red-black pushes because usually we push in the morning hours when ASG are at half or maybe even at less than half of their capacity. Regional failover, it's an interesting use case. You see a picture of Kong because this is internal name for regional failover, for the system that does regional failovers. Netflix operates in 3 regions. We have the ability to fail out of any single region and serve our customers, all our traffic from the remaining 2 regions. Now, how autoscaling helps with that? If you think about this, for example, Virginia versus Ireland, we see the time shift in peaks between these 2 regions about 7, 8 hours. So when we fail traffic out of Virginia, the bulk of it goes to Ireland. We don't have to provision Ireland for the peak of peaks. We have to provision it only to hold the local peak. It's like adding 2 sine waves that are shifted. It's not doubling up, it's much less than that. And lastly, it's an interesting use case. I wanted to call it out. It's a Hack Day project that's not something that we usually do, but it illustrates the power of dynamic scaling. Folding at Home is a Stanford project, folding proteins, finding cure for cancer. Unfortunately, it's not there yet, but hopefully one day. As a part of Hack Day project, one of our engineers joined some of our off-peak capacity to folding at home and helped curing cancer. Lastly, I want to call out that autoscaling is not a random scaling. A lot of times, I hear comments from folks, sometimes teams internal in Netflix, sometimes folks outside of Netflix. The concern is, what does autoscaling do to my ASG? Will I have enough capacity? Will I have too much and end up paying extra? Well, it seems like some kind of black box that does it randomly or magically. No, autoscaling has a very well-defined set of rules, and if you understand your performance band, your performance characteristics, and if you understand your traffic patterns, then you can set up autoscaling rules so that autoscaling always keeps you in this performance band and saves your cost. Let's get to setting up autoscaling. And the first question you will have to answer is which metric to scale on. Tara mentioned it in her presentation that this was one of the feedbacks from the customers. Easy metric setup. How do we choose our metrics? I can totally relate to this because I get these questions all the time. That's how it goes. The guy on the right is me. The guy on the left is service owners. And the question is, which metric should I scale on? And the answer is, you should scale on something that shows how busy your instance is, and that changes proportionately with the size of your ASG. In my experience, this answer, well, actually doesn't answer the question, because usually what happens, service owners say, okay, let me explain what my service does. Here, it does A, B, C, all to Z, and by the way, it's a very important service. Now you tell me which metric to scale on. Okay, I got it. Here, which metric explained? There's two general buckets, throughput and resource utilization. Throughput measures how much work is being done. Resource utilization measures, well, how strained is your resource. It's very easy to relate to this. Imagine you're running a marathon, your throughput is how many miles you ran, and your resource utilization is, say, your heartbeat, because that could be a proxy for how tired you are. AWS provides a few metrics. By default, request count per target. I believe that's the metric Tara used for her demo. It's a great metric. It shows how many requests per instance ALB is processing. CPU utilization, again, it's available by default. Good metric to scale on. Both of these metrics, both of these classes of metrics have pros and cons. The pro of throughput is that it's very, very intuitive. It's a direct measure of your work. Usually, if your request mix is homogeneous, it's a great metric to scale on. It's also intuitive in the sense that if, let's say, you know your total expected throughput per ASG, and you know your target, you can divide one by another and arrive to the number of instances. You can sum up throughput for each individual instance and arrive to the total throughput of ASG. Very intuitive. Cons, it tends to drift over time, obviously, as we push out new version of our code, as we add more features. Usually, it's not uncommon that request becomes heavier and we need to adjust our target. CPU utilization is a little bit more forgiving in this sense. It's from 0 to 100. You can always say scale on 50%. Even if your request becomes heavier, ASG will still keep you at 50% CPU utilization, probably at the cost of extra capacity. But you can do it. It's prone to drift as well in the sense that if the older version of code was able to operate normally at 50% CPU utilization, the new version of code might not be able to do this. You always have to watch the targets. In our experience, we noticed that CPU utilization have slightly more oscillation and jitter. Again, if you run maybe some kind of periodic tasks, refreshes on your ASG, that can affect your CPU utilization, that can push it a little bit higher, but your mileage may vary. One more thing I wanted to call out about throughput is that depending on how you measure your throughput, you can get different results. Let me give you an example. Let's say we have a service that watermarks documents. You post a document, service processes it, watermarks every page, and spits it out. What is my throughput? If you measure throughput in requests per second or documents per second, that might not be the best metric for the work you're doing, because each document is different. One document can have 3 pages, another one 23 pages. However, if you express it in pages per second, then you equalize your unit of work, and now it's a more precise throughput metric, and it's more suitable for scaling. Scaling on multiple metrics is something that is very, very tempting to do. It's certainly possible to do this. It's fully supported by AWS. You can set it up. The issue becomes it gets harder to reason about scaling behavior. It gets also a little bit harder to control the metrics, because you can run into situations when different metrics point into different directions, and autoscaling might start oscillating. At Netflix, we follow this typical setup. Normal scale up and scale down on throughput, requests per second. Emergency scale up on CPU, we call it the hammer rule. If something, God forbid, happens, we have a spike in traffic, or for whatever reason, CPU spikes up, drop the hammer, scale up, survive this surge. When I say normal scale up and scale down, for step policies, these are 2 separate policies. For target tracking, obviously, it's a single policy that controls both scale up and scale down. Next is setting the target. Now that we know our metric, we need to set the target. This is probably the most influential decision you will make for your ASG. How do we set up the target? There is plenty of tools available to generate traffic. Well, curl is not entirely a performance testing tool, but if you want to generate 3 requests per second, why not? I've seen people doing this. There is a lot of tool that can generate synthetic load. There is a lot of tool that can capture and replay the traffic. There is a lot of open source solution. There is a lot of commercial solutions for that. And they're all great, and they solve certain aspects of this problem. What they doesn't solve is, even if you start replaying traffic, you need to make sure that the traffic you captured in prod and replaying in your test or dev environment, it hits the same data set. Keeping environments in sync quickly becomes a nightmare. Netflix answer: run squeeze tests in production with a live production traffic. Here's how. This is an example of mid-tier service. We have a server ASG with a certain AMI. We have client ASG sending traffic to the server. We clone our server ASG with a single instance. That would be our target squeeze ASG. We also spin up an instance of a proxy. Then we start diverting traffic from our clients to the proxy. Proxy splits the traffic. It measures the exact throughput to the squeezed ASG. The rest of the traffic, the excess, goes back to the server ASG. And controlled throughput, this is our measure. This is the result of our squeeze. We can use it as our target. This approach allows us to use our live production traffic, which is the exact traffic that we will get in real usage scenarios. And this would also allow us to minimize the blast radius. We do not squeeze the whole ASG. We squeeze only a single instance, and we have mechanisms such as retries to recover if there is any failures during the squeeze test. Speaking of failures, in my opinion, it's extremely important to understand your failures. I know nobody likes to think about it, nobody likes to talk about it, but as a performance and reliability engineer, I deal with failures day in and day out. So here's an example of two services. Service on the left can ramp up the throughput from roughly 100 to maybe 180 requests per second. CPU utilization goes from 40 to 80%. Latency almost doubles from about 30 milliseconds to 58, 60. But the service still able to process all incoming requests. It's all good. The service on the right, however, have a very distinct break-in point. At some point, even though our CPU utilization is relatively low, the server falls off the cliff, latency shoots up to the point that I have to use logarithmic scale to plot this graph. It goes from milliseconds to over a second. CPU utilization goes to close to 100%. This is a failure. What's the difference? This is the difference between these two scenarios. Service on the left keeps going, service on the right fails. How is it related to autoscaling? If you have the good service, the service on the left, then it's a business decision at this point. You can choose to operate it at a lower CPU utilization, lower latency, at a higher ASG size, pay a little bit more, but get the latency, get the low latency. If you don't care about latency between 30 and 60 milliseconds, you can run it hotter and save money. The service on the right, you do not have the same luxury. You have to make sure you operate it well below the point where it breaks. Now we know our metric, we know our target. Let's get to setting up scaling policies. Here is an example of an ASG with a scaling policy on throughput. The graph on the top represents the ASG size, that's the gray area, versus throughput, that's the pink line. The graph at the bottom is the throughput per instance. Yellow and blue lines are our threshold, scale up and scale down threshold. First of all, you can see that even visually, the size and overall throughput, they kind of match. They're about the same shape. But the bottom graph is more telling. This is how autoscaling operates. It keeps your target metric within a band. With step scaling policies, you used to set this band explicitly by scale up and scale down thresholds. With target tracking, there is an implicit band, but it's always a band. For as long as your metrics stay within the band, autoscaling doesn't do anything, doesn't scale up, doesn't scale down. It keeps you steady. When the metric goes above your scale up threshold, above your ceiling, it gives you more capacity and your throughput goes down. And as the traffic increases, it repeats. So when the traffic increases, we keep bumping up against the ceiling and getting more capacity. On the way down, we're bumping up against the floor, removing capacity. Autoscaling always tries to keep the metric within the band. Sounds easy, must be easy to set up. Let's see what could go wrong. Here's a few examples. No rush scaling. Well, you can see even visually there is something wrong. If you compare it to the previous slide, the shapes do not match, and the throughput per instance goes way below the floor and a little bit above the ceiling. In this particular case, the team that set it up, they confused the scale up by the number of instances versus the scale up by the percentage of ASG size. That's one of the parameters step scaling policies allow you to choose. As you can see, the size of this ASG, about between 300 and 400 instances. At this point, scaling by 5 instances versus 5%, it matters. In this case, autoscaling does what it's supposed to do, but it simply cannot keep up with the traffic. The solution in this case is to increase scaling amounts or migrate to target tracking. Target tracking doesn't have this problem. Everything is managed for you. Another example, Twitchy scaling. This ASG doubles up capacity as soon as our throughput metric reaches the scale-up threshold. When I spoke with the service owners for this particular ASG, and I asked them, why did you set it up this way? Their answer was, we wanted to make sure we have enough capacity, but we don't really know how much is enough. We're not sure how much traffic we're gonna get. So doubling up seemed like a safe bet. Okay, well, the problem with that is that once you double up, your scale down policy starts scaling you down immediately. So all it achieves is just an instance churn. Target tracking obviously doesn't have the same problem. It always keeps you in the band. It doesn't give you oscillation. And lastly, this is my favorite example. Should I stay or should I go? There's a little story behind this example. One of the teams discovered a performance regression in one of their services. They discovered it on Friday. So they have a choice: push a fix going into the weekend, or scale up, stay throughout the weekend, and push the fix on Monday. They chose not to push on Friday, which is considered our best practice. That's great. Adding capacity to survive the weekend, good decision. What happened is they lowered their scale-up threshold. They lowered the ceiling, but they didn't lower the floor. So instead of a band, it became a single line. Both scale-up and scale-down thresholds are exactly the same. What happened is ASG started oscillating. Obviously, again, I'm repeating myself, but I think it's worth it. Target tracking doesn't have this problem. In terms of setup, going back to customer feedback, Speedy setup, it's about 10 fields versus 3 in target tracking. This is a screenshot from Spinnaker, our deployment system. It's open source, by the way. You can use it as well. But it's closely, in this particular case, it closely resembles AWS console. Instead of specifying thresholds and scaling amounts and the number of evaluation periods, you just specify your metric and your target and warm-up time. That's it. But wait, that's not it. For step policies, you have to specify both scale up and scale down, and you have to make sure they're aligned. Target tracking doesn't have this problem. Single policy controls both scale up and scale down, just the metric, target, warm-up time, and it scales by the virtue of autoscaling magic. And lastly, the traffic patterns. I think it's very important to understand your traffic patterns. Here is an example. What is common between all these kids shows that are available on Netflix and this traffic pattern? Here, it turns out that Saturdays have a much steeper traffic ramp up in the morning hours, and it's been attributed to kids watching Netflix early in the morning instead of going to school, as they do on a weekday. How does autoscaling react to this? Let's see. This is a zoom in on Saturday morning. As you can see, the traffic ramps up much steeper as compared to Friday. Saturday, more volume of traffic. Why am I talking about mornings instead of peak times? Because usually when people talk about autoscaling, the question is, will I have enough capacity to handle my peak? The answer is yes, autoscaling will give you this capacity. It will give you capacity up to your ASG max. Actually, the more salient problem here is that when the ASG is at the lowest size and you have sharp increase in traffic, can autoscaling keep up with increasing demand? You have only a few instances to spread your traffic across. At peak, you have much more. To answer this question, we did an experiment. We ran one service with our reasonably well-tuned step policies. Then the next week, we run it with target tracking on the same threshold with the same target. And here's the comparison. Blue line represents the behavior of target tracking. Yellow line represents the step policies. In terms of per instance throughput, you can see that between 4 and 5 a.m. in the morning, step policies gives us higher throughput. They both are slightly above our target, but step policies go higher above the target, and this is the danger zone. Step policies cannot keep up with this traffic. Then, if you look from 6 to 7 a.m., step scaling policies all of a sudden give us more capacity. The ASG runs slightly cooler than it could have. And if you look at ASG size, unsurprisingly, target tracking gives us a little bit more capacity early in the morning and a little bit less capacity later in the morning between 6 and 7 a.m. Essentially, it saves us from trouble early in the morning, and it saves us money later by simply keeping the target closer, tracking the target closer. When you look at these graphs, you might say, okay, well, it doesn't seem like we save much. But actually, keep in mind, this is a relatively small ASG. On our larger ASGs, we see bigger savings. For example, in this particular case, the savings over the week estimated about 4%. That's a pretty decent result, especially considering that we didn't invest any time in tuning auto-scaling. Target tracking did it for us. It's just set it and forget it. To summarize, target tracking gives us easier setup and better demand tracking. Easier setup results in increased productivity. Better demand tracking gives us reliability. I wanted to talk a little bit more about productivity. When I say productivity, it's not that I'm not talking about filling out 10 fields for step policy versus 3 fields for target tracking. It's more how teams use it. What we noticed is that step policy is extremely powerful, but setup was not obvious. So teams was avoiding changing their scaling policies. They were not really looking at their demand. they were not really tracking it. With target tracking, it becomes so easy and so intuitive that teams pay more attention. It's very easy for them to stay on the top of their performance characteristics and capacity demands. And productivity alone, in my opinion, justifies the move to target tracking. And by the way, by increasing productivity, ultimately, we save cost. But again, that's not it. There is another AWS innovation: per second billing. Combined with better demand tracking, it gives us reduced cost. We spin up capacity only when we need it. And target tracking is very good at reacting quickly and giving us exactly the amount of capacity that needed to process the incoming traffic. And that is how target tracking hits productivity, reliability, and cost. It's not a zero-sum game. You can get all three of them. If you don't use autoscaling, start with target tracking. If you use step scaling policies, I encourage you to migrate. I encourage you to at least give target tracking a try. Thank you.
Thank you. Thanks, Vadim. Thanks for sharing your autoscaling learnings and lessons from Netflix. Hopefully, it will help others to avoid some growing pains. And as you said, encourage you, if you haven't tried target tracking, we make it really easy. There's some great resources on our Getting Started page, or if you want to try autoscaling with one of our new autoscalable services like DynamoDB or Aurora. And for us, we love to hear how our customers are using our services. So if you want to share at #autoscaling what you're scaling and how you're scaling, we'd love that. Maybe you'll be on stage with us at the next summit. Thank you for your time, and enjoy tonight. Enjoy the rest of reInvent.
Thank you.